Now we shall see how to solve the corner isolation problem using the tiling algorithm. So we are given the corner isolation problem in which the patterns which are indicated with blue crosses belong to class 1, that is -1, -1, -1, 1, 1, 1 and 1, -1, and rest of the patterns belong to class 2 as indicated by zeros. So first step is that in tiling algorithm we shall be naming these patterns with some alphabets. So these are the names which are given. Now based upon this we can form the pairs of class 1 patterns and class 2 patterns. So any class 1 pattern and any class 2 pattern. Now as we know that the alphabets, which are the alphabets that belong to class 1, the alphabets that belong to class 1 are A, B, C and D. These are the alphabets which belong to class 1, and then there are alphabets which belong to class 2, and those alphabets are given as E, F, G, H, I. Now based upon this we shall be forming the pairs. So the pairs can be written as, first pair will be, I will be writing in terms of A. So it is A, comma E. Second will be A, comma F. Third will be A, comma G. A, comma H. A, comma I. Next we shall be writing in terms of B. So the pairs in terms of B will be B, comma E. B, comma F, B, comma G, B, comma H, B, comma I. So similarly we can write the pairs in terms of C and D. So the pair in terms of C is C, comma E, C, comma F, C, comma G, C, comma H, C, comma I. And then last we can write the pairs in terms of D, D, comma E, D, comma F, D, comma G, D, comma H, D, comma I. Now the purpose of this particular algorithm, that is your tiling algorithm, is to separate these particular classes, to separate these particular pairs. So the line should be selected such that these pairs get separated. So because they are now A and E, where is A and E? A is from class 1, E is from class 2. So the line drawn here should be such that it will be separating A and E. Similarly, if at all I want to separate B and H, where is B? B is here, H is here. So line has to be drawn somewhere here or here or here, anywhere, such that these particular patterns B and H are separated. So at the beginning we shall be selecting a random line and see how many pattern pairs get separated by the choice of that particular line. So first, step 1. Now in step 1 we will be selecting the first line, or which will be corresponding to the master unit. So we can select anywhere. And this name, the name of this line, we shall give it as M1. So in this particular line, you should ensure that there are minimum number of misclassifications. And when you ensure in a corner isolation problem, minimum number of misclassifications are 3, right? So if at all I select line here, M1, if this line I am naming it as M1, there are minimum 3 misclassifications, 1, 2 and 3. So these are the 3 misclassifications. So which are there? So which is class 1? This direction is class 1 because I have 2 samples out of 3 samples, 2 samples are belonging to class 1. Whereas on the other side, out of 6 samples, 4 are belonging to class 2 and 2 are belonging to class 1. So usually the trend is that we will be taking the direction of class 1 as positive. So that is the reason M1 direction I have taken this way, in this particular direction. So it will be indicating class x1 is equal to minus 0.5. so which can be reduced as x1 plus 0.5 is equal to 0, but the direction we have taken in the negative x1 direction, and 0, 0 point should not be line, so I reverse the sign, so I get this particular equation. Now, whenever we have taken this particular line, that is M1, we see which of the pairs are getting separated. Now, which of the pairs are getting separated here is that this side is, first we'll take with respect to C. So, the patterns of C, which are on the C and F is not getting separated because they are on the same line, same side of the line, whereas C and I, H, G and E get separated. So I can, cancel this pattern from the set of the pairs. So which are the patterns? C and E get separated. C and G, C and H, C and I. Only we are left with C and F. Now, coming to F. Now, which are the patterns which get separated? Now, with respect to F, there are only two patterns, A and B, which are lying on the other side. So, FA and FB will get cancelled. That is A, F, B, F. Similarly, going to D. Now, with respect to D, only F and D are not getting separated. Rest B, E, D, G, D, H, D, I, all these patterns get separated. So, at the beginning, we had 1, 2, 3, 4, 5, 20 pairs. So, at the beginning, we had 20 pairs, out of which 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, using this particular line M1, 10 pairs have got separated. Okay, so 10 pairs have been separated. Now we select the next line, and this next line will be corresponding to the ancillary unit M1. So next we select a line A1, that is somewhere here. I select this A1 line here, and the direction is upward direction. So this line is A1. So what is the equation of this particular line A1? The equation of A1 will be nothing but x2 is equal to 0.5. That means it will be x2 minus 0.5 is equal to 0. So again 0, 0 point is not lying in this positive region. So the equation is correct. A1 x2 minus 0.5 is equal to 0. This will be the equation of the ancillary unit 1. Now if at all you see here, which are the patterns which are getting separated? Now D, starting with D, now D pattern was not, D and F pattern was not separated earlier, but this line, it will separate this particular pattern. So now I am using a different way to cancel, although I have a lot of colors, but you will be having just a pen. So you can use a backslash here. Previously we had used a forward slash to cancel. So we use a backslash to cancel D, F. I expect you to write these pairs again. Okay, here I am using the same pairs and I am cancelling it out. But you can write it again, or whichever pairs I can, you can cancel or whatever. Or you use a different marking scheme so as to indicate which pairs got cancelled with which particular line you selected. So D, F is getting cancelled. The pair is going because it is separated by the line A1. Similarly, now I see E. Now E and A is not getting separated, but E and B is getting separated because of this line. So B, E also I can strike off, and C, E is already separated. So now E and A is left. Now with respect to A, which are the patterns which are getting separated? The patterns which are getting separated are A, H, A, G and A, I. So these three patterns are also getting separated. So how many patterns altogether got separated here? There are 6 patterns which got separated because of this. Now if you see here, from A, E is remaining, C, F is remaining, and rest all are from B. So 5 pairs are remaining to be separated. So I select the next ancillary unit, which is A2. So in step 3, we select another line corresponding to the ancillary unit A2. So I select the line such that A and E will get separated, and also C and F will get separated. So I take a line like this such that A and E and both C and F will get separated. So I take direction as this direction such that A and E and C and F will get separated. So I can take the equation of this line as x1 upon minus 0.5 plus x2 upon 0.5 is equal to 1. So this point is minus 0.5 and this is your 0.5 here. So I can write this equation as minus x1 plus x2 minus 0.5 is equal to 0. Now 0, 0 point is lying in the direction of this particular point, that is here, in the positive direction of this line. So that is the reason we have to change the sign of this equation, and it will become x1 minus x2 plus 0.5 is equal to 0. So with this particular line which we have taken, we have seen that E and A will get separated here and C and F will get separated here. So I can strike this off. I'm using a dash in order to separate it. Every time I am cancelling the pairs, I am using a different way to indicate. So I am just striking it off by using this particular sign. So now, if I told you, see, in this particular step, step number 2, two pairs get separated. Two pairs get separated. Now we are left with 3 pairs, B, G, B, H and B, I. So this pair, it is very easy. You can separate it by using a line like this or using a line somewhat like this. Okay, anyhow you can separate this particular, because you need to separate B, H, B, G and B, I. So maybe you will be drawing a line like this in order to separate these patterns. So in step 4, we have to select this line. So we select this line with a direction with this side. So the equation of the line again will be x1, so this is A3, x1 upon 1.5, assuming that this point is 1.5 and this is minus 1.5. So in the intercept form, two-intercept form, I get this equation x1 upon 1.5 minus x2 upon 1.5 is equal to 1. And that will correspond to x1 minus x2 minus 1.5 is equal to 0. So since 0, 0 is not lying in this direction, we can say that A3 is nothing but x1 minus x2 minus 1.5 is equal to 0. Now this particular line will be separating 3 pairs. 3 pairs will be getting separated, which were left. So I double strike these pairs so that I know that, in this particular step I use double strike. So every time you can just indicate what is how you are striking it off. So that needs to be indicated. So in step 4, so at the end of step 4, we have come to conclusion and say that all the 20 pairs are separated. In the first master unit, we had separated 10 pairs. Thereafter 5 pairs, thereafter 2 pairs and thereafter 3 pairs. So you have to, continue this problem till all the pairs get separated. So now we have to draw the neural network according to the tiling algorithm. Okay, just please note this as A3. I did not indicate this line as A3 and this one as A2. So in this particular case, we have seen that there is 1 master unit and 3 units. So these are the equations for M1, A1, A2 and A3. which we have got. Now we shall draw the neural network with the help of these equations. So these equations we just move somewhere here. So the first, how many inputs are there? There are two inputs, x1, x2 and one bias. So 1, 2. So from this I shall be connecting the weights to the master node, that is -1 and -0.5. So this is the master node indicated as M1, this is A1, this is A2 and this is A3. Next we go to the node A1. So here it is x2 and here this one it is -0.5 is the weight for the bias. Third A2, it is the weight is 1, -1 and +0.5. Next is A3. Again it is 1, -1 and -1.5. Now from the second node, what we will be having is that we will be having the second master node, and the weights from the hidden layer to the final layer, all weights will be 1. Uniform weights 1. So that is what is the technique which is used here. And now a very important step here is that these are the lines which we have got for tiling algorithm. We just have to check what will be the output of M1, A1, A2 and A3 for all the patterns. So M1, A1, A2 and A3 we want for all the patterns from class 1 and class 2. So first we shall take the patterns from class 1, 1, -1, -1, 1, -1 and -1, 1. So if at all we take these particular patterns, what outputs shall we expect? How we come to know is that now this process required for calculation of the bias. So I can just get it quickly looking at the lines. So where is the pattern 1, 1? 1, 1 will be here. Now for this, direction of M1 is negative. So it is not in the direction of M1. The M1 direction is this side and this pattern is on the other side. So M1 will be negative. A1 is positive because it is in the direction of A1. A2 will be again positive and A3 will again be negative. So because it's not lying in the direction of A3. Similarly for point -1, -1. This is -1, -1. That is this point. Okay. If you see M1 is positive, A1 is negative, A2 is positive, A3 is negative. Similarly for point 1, -1. For point 1, -1, here M1 is negative, A1 is negative, A2 is positive, A3 is positive. And for the last point, -1, 1, if I don't see for that point, M1 is positive, A1 is positive, A2 is negative, A3 is negative. So I can calculate what is the value of net. Net will be M1 plus A1 plus A2 plus A3. And you see that net will come 0 for all these points from class 1. Similarly, if at all you take the points from class 2, if at all you take these all points are from class 1, not from class 2. Similarly, I can take the points from class 2, 0, 1. So for the patterns from class 1, we will also calculate M1, A1, A2 and A3. Now this we can do from the directions. So 0, 0, M1 is -1, A1 is -1, A2 is +1, A3 is -1. So I can calculate the net will become -2. Similarly, for the point 0, 1, this one. Okay, M1 is minus 1, A1 is plus 1, A2 is minus 1, A3 is minus 1, net is minus 2. Similarly for the point 0, minus 1, this point, M1 is minus 1, A1 is minus 1, A2 is plus 1, A3 is minus 1. Similarly for the point 1, 0, where is 1, 0 here? So for this point, M1 is minus 1, A1 is minus 1, A2 is plus 1, A3 is minus 1, and minus 1, 0 point, M1 is 1 and rest all will be minus 1. So similarly here you get what you get is net is minus 2. So what we can select the bias can be selected as, say, somewhere it should be lying between minus 2 and 0.5. The bias should be such that if at all I add a 0.5 to this, what it will become? It will become 0.5. Or I can keep the bias as, say, 1, such that, so when I add a bias of 0.5, this will still be negative and this will become positive. So I can select a bias which will be, separating the patterns from class 1 and class 2. So I select the bias as 0.5. So the bias will be selected as 0.5 in this particular case. And selecting the bias as 0.5, we can just draw the network. So what you have in the network is, here if at all you see the net calculation here will be nothing but M1 plus A1 plus A2 plus A3 plus 0.5.